A potassium ion is known as a cation because it has a positive charge. The charge is determined by looking at the periodic table. Potassium falls under group 1 on the periodic table, otherwise known as the alkali metals. The charge of an element can be determined by its valence electrons, or electrons in the s and p orbitals in the farthest electron shell. Using the shorthand configuration of potassium, it is obvious that there is one valence electron. Looking at trends of electronegativity and ionization energy, we can see that atoms in group 1 of the periodic table have the lowest electronegativity and ionization. Electronegativity and ionization increase as you move from left to right or bottom to top on the periodic table. This means that potassium is more likely to lose its valence electrons than to gain one more. Their goal is to reach either 0 or 8 electrons. Because potassium will lose one of its valence electrons to oxygen, potassium can now be viewed as potassium plus 1.
An oxygen ion is known as an anion because it has a negative charge. Its charge can also be determined by looking at the periodic table. When looking at the shorthand electron configuration for oxygen, it is obvious that there are 6 valence electrons. In addition, oxygen falls under group 6 on the periodic table. This also means that oxygen has a high electronegativity and ionization energy. Oxygen is more likely going to take 2 valence electrons than lose 6. Oxygen can now be viewed as oxygen 2-.
Now comes bonding. The oxygen ion will take the potassium ion's 1 valence electron. This leaves the potassium ion with a neutral charge. However, the oxygen ion still has a charge of 1+. This can be solved by adding in another potassium ion. Now all atoms have a neutral charge.
So why were arrows used? Arrows were used to show that, in ionic bonding, electrons are leaving the element. In covalent bond, atoms would be right next to each other, signifying that they shared electrons. Since the electrons are taken rather than shared, arrows are used to show that electrons are forcibly taken. This results in their compound, potassium oxide.